more dynamic testing safety certification that we are accredited to. So in the automotive industry, ISO 26262 is a key focus for us. Our products ship with a certification pack to prove its worthiness in that industry. And likewise across industrial automation, medical devices, railway, and so on. We also have a verification pack for our automotive, aerospace and defense customers. So if you're working towards Tier 178C or D, we can supply a verification pack to help you prove the testing process your code is going through in conjunction with our technology. The lower half of this slide here are mainly coding standards, so kind of slight adjustments to the underlying C and C++ languages, which have been adopted in various industries. So the key one here is MISRA C, MISRA C++. That's a safe subset of the C and C++ language that makes coding in those languages more memory safe. We have a static analysis solution to help prove your code meets these various guidelines. So aside from proving code works and it isn't going to fail in use, the main driver outside of that for our business is to help our customers shift left. So that means moving the defect detection point from maybe latter stages of development where they're quite costly to fix, down to the earlier stages where you're actually designing and coding the solutions. So our products sit down here at the coding and unit test side and help you assure that your software isn't going to throw up bugs or defects at latter stages of development, or at worst at release time. So our three main products are Cantata, QA MISRA, and Astri. Cantata is where I'm going to spend most of the time today. This is our dynamic testing solution. It allows you to put together a comprehensive unit testing suite for safety critical C and C++ code. It has quite a number of automated testing features. So these do everything from setting up boilerplate code, test scripts, test data, and so on, right through to the current cutting edge of bringing generative AI into that mix, which has been the focus of my work for the last 2 or 3 years. Cantata also comes back with comprehensive code coverage reports, so you can prove that the entirety of your software base has been well tested. And we also have links to various requirements tools that you might be using to prove that you've tested according to the requirements for your software. The lower half of this slide here is our static analysis solutions. So static analysis differs a little bit from dynamic testing, whereas in dynamic testing, you're actually building small segments of your code base and exercising it down various paths with test data. On static analysis, this is more akin to like a spell checker or a grammar checker on the code. So we're not actually building or running any code with these tools. We're looking at the syntax of the code, checking that you've met various coding standards like the MISRA rule set that I mentioned before. Our Astri product is a more advanced static analysis solution. So this uses advanced mathematical algorithms to try and predict defects before they occur in the compiled software. So I'm going to take you through quite a quick introduction to our classical Cantata software, our dynamic testing tool suite. I'll start with a few pieces of C code, and hopefully we'll see how quickly we can spin up a suite of tests against that code. Once I've shown you the kind of more classical way of using the tool, I'll explain the work that I've been doing for the last few years on the AI side. We'll look at some AI agents and explore how they can help accelerate our workflow in these environments. So that's basically the end of the PowerPoint section, until we get to the Q&A placeholder slide at the end. I guess nobody's got any questions at this point before I start showing the software, but if you do, I'm happy to take them at this point. If there's silence, I will carry on. Okay, so I'm operating inside a virtual machine, a virtual Linux machine here, and I'm doing that primarily because I'm going to be using some agentic AI later in the demo. And with AI systems, you don't really want to give them full control of your main machine. While things are pretty safe in the AI world currently, it is possible for the AI agents to write to and modify files across your system. So sandboxing it in a virtual environment is a good safety measure, something I would recommend. But we're not going to touch on AI just yet. I'm going to show you an initial use case for using our Cantata tool, which is loaded up here, to generate some unit tests against two pieces of C code. So these have come from one of our automotive customers. We've got brake.c and motor.c, and these form the key elements for a anti-lock braking system on a vehicle. So it's quite a critical system, something that you don't want to go wrong while you're driving at high speed or when you're wanting the system to apply an emergency stop. And it's quite important that this code functions correctly 100% of the time. So break.c, I chose these files because it is quite a compact example. Break.c controls the braking force applied to particular wheels in the vehicle. It's around 300 lines of C code, and you can see as we go through this, we've got various paths that we can take. So if we're exercising this code at the unit level, we want to come up with test data that will drive the code down each of these possible routes, and we want to monitor that we've achieved that level of code coverage. So that's break.c, and we've also got motor.c, which is a similar size, and this is being deployed on a electric vehicle. So as well as the anti-lock braking system controlling the brakes, it can also control the amount of power going to the motor for each of the wheels. And again, as you look through this, you'll see that the code has been fairly well written. We've got nice comment blocks, and we've got reference numbers which link back to the requirements for that piece of code. And that will become more important and more apparent as to why that's useful to have in the code later on in the demo. So this is our starting point. We've got to imagine that I'm a junior engineer that's maybe in his first week of the job. He's started working at BMW. He's been given these two pieces of code, and he's been asked to test that according to industry standards. So as a junior engineer, I probably spend a day or so reading the requirements, looking through the code, maybe doing some test compilation of the code to make sure it runs. And then I'd start to figure out some test data that I'd need to exercise this code base. Now, Cantata can help with quite a few of those sections. So the first thing I want to do, because these pieces of source have been pulled from a complete system, they don't come with their own entry point. We don't have a main function. They've not been designed to be compiled and executed away from the complete system. So the first thing I'm going to ask Cantata to do is to give me that entry point. So I want it to look at the code and kind of do some analysis and give me some tests into that code. So I'm going to generate a new piece of code to give me that entry point. I'm going to pick a coverage target, so a rule set that I want to work towards in the course of doing these tests. So I'm going to pick something quite comprehensive here. So this is basically the highest safety integrity level coverage requirements. We've got entry point coverage to make sure that every function in this code has been exercised, statement coverage to ensure every line, if you like, of that code has been exercised, call return decision coverage. So on these if blocks, we want to make sure we've gone down each path, right through to full MC/DC coverage, which if you're from the aerospace industry will mean something. MC/DC coverage looks at complex Boolean expressions in the code and makes sure that you've exercised the code by holding each element of that Boolean expression unique. So Cantata can verify our tests have met all of those conditions. I'm going to turn on the auto test function here. Now, what this does is invoke some additional mathematical analysis of the code. So rather than giving me just kind of basic boilerplate to drive the software, Cantata is going to do some analysis and come up with some likely test data that is going to achieve high levels of coverage out of the box. So if I hit finish, we should see down in the corner Cantata doing some work on building that. I just switch. So behind the scenes, Cantata has compiled that source code just to make sure there's no compiler bugs. It's done that mathematical analysis and it's put together this new piece of code here. So I can click into that. This source file has been written in those few seconds that I've been talking, and we've got several thousand lines of code here that have been generated algorithmically by our system. So we could look through this in a little more detail. Let's go back up to the top. First thing that we would want to do when we're isolating this from our more comprehensive system is look at things like global data and global functions. So this code will expect some things to be in place. So it will expect to be able to talk to some external functions. It will expect some data to be in place already in memory. Cantata can figure out what that data is and automatically set that up for you in this new piece of code that is generated. If I just scroll down a little bit, you can see that we've got a main function contained in here. So what this enables is for this piece of source code, atestbreak.c, to be compiled just with these two source files, and you get a complete compilable binary. Now with that binary, you can either compile it with a host-based compiler, which I'm going to be doing here. So I'm using GCC on my virtual Linux box, and then that will give me a binary that I can run on this system. It's quite easy with Cantata to switch the compiler we're using just with this drop-down box. So if I was using a embedded C compiler targeting an actual embedded chip, I could just pick up the compiler configuration that I want to use, and then our test binary we can flash to the device and check that the behavior is correct in situ. So I guess the next thing to do is to compile this and actually get some results. So let's switch over to here. We can compile and run those tests, and we can see the output coming on the screen at the bottom. So again, this is console output. What we're basically doing is sending these source files through to the compiler, linking it together, and then immediately doing a run. This console output is quite interesting. we're working inside an IDE at this point, but behind the scenes we've got a complete makefile system that will build and run this test that we've generated. So this compilable unit with its own independent build system can be dropped into your CI pipeline, and you can use these tests as regression test suites. So as the code base changes and matures, you can rerun your tests and check that you're not breaking anything. We get coverage information coming out, so you can see that initial set of tests there are achieving 96% statement coverage. So we've done very well. Remember, if I was this junior engineer, I think it would take me a week or so to figure out all the test data required to drive the code down all the paths and get that level of coverage. We can click in a little more detail, so I can expand this. I can look at break.c. I can look at the individual functions that we're calling. I can see some of these we've fully covered. So if I click into the source file, we've now got color coded coverage information. So everything in green has been exercised by those tests. If I look at something that hasn't been fully covered, we should start to see some yellow and red appearing on this output. So this if condition, for instance, if I expand that, we can see we've exercised that particular point of the code with this test suite 9 times down the false branch, but we've not yet hit a true case. So we've not come up with a piece of data where we can satisfy that condition in a way that we exercise this line of code that's being highlighted in red. Now, remember, we came up with this test data algorithmically, so possibly this is highlighting maybe a piece of code that has a bug or an error in it. It just means that it's going to be very difficult to exercise that line of code, and you need to start to apply some manual brain power to figure out why that is, because possibly that's highlighting an error. We also get comprehensive reports and results files coming out of the system. So we have a HTML report. Open up Firefox. So this is the results file from running that test. It's a standalone HTML file. You get the same file coming out of the system regardless if you exercise these tests in the IDE on the target hardware or if you run them in your CI pipeline. And it's this file here that the certification body will want to see and want to sign off on. So we've got very detailed tests coming through here. We've got the test data being passed in, and down at the end we've got a full check for the coverage information that we're receiving. Now, remember, we didn't hit 100% coverage on this initial pass, possibly because of bugs in the code. So the overall status of these tests is fail. So that is a very quick overview as to what you can do with Cantata. You can press a few buttons, and in a few seconds, if I wasn't spending the time talking over the top, you can come up with quite a comprehensive set of tests that verify the code does what the code actually does. The piece that's missing in here, and the piece that I've been working on with my generative AI systems, is how to drive this initial set of tests, this set of test data, so that it aligns more with requirements documentation that we might have available. So up until beginning of last year, as a test engineer using Cantata, it would be down to me to verify all of this test data that we're pushing into the system actually aligns with the requirements for that piece of code. And now with generative AI, we can short circuit that part to some extent as well. Obviously, you still need some degree of manual verification, but in the same way, we can always get our boilerplate test code quite quickly. We can now do an initial scan of the test data against any requirements that are in the system. So if I minimize our Cantata system, and I'm going to drop into VS Code here just so I can show you some requirements files a little bit more easy. So in this break demo 2 folder, I've got the same pieces of code that we were working on inside the Eclipse Cantata IDE. So we've got break.c, same file with the same requirements hooks through it. And we've got motor.c, again, the same file. But I've also got a markdown file here called requirements. Now, this is a export of the requirements for this system. It actually got generated from Polarion, which is a requirements management suite. The fact that it's come from Polarion doesn't really matter. It's just a piece of text that has some more detailed requirements in that we can bring into our testing kind of environment. So these requirements have the same requirements tags through them as were present in the code. And it goes into a little bit more detail for each of these requirements. So we've got an initial human readable reason why that requirement is in the system. And we've got a little hint to the person trying to test against these requirements, how you might go about doing that. Now, these are just hints. So there's something a kind of project manager or a more senior engineer might type in, might be an instruction to a junior engineer before they start going about writing the test code for this. So this is fairly comprehensive, just to give you an idea of the size. So we've got about 250 lines of requirements here. I was trying to pick something that was maybe reasonably well spec, something that was representative of the industries that we work in without going over the top with the amount of detail in these requirements.
Adam, 1 second, there is one question here.
Yeah, of course. Sorry, I'm not looking at the hands being raised I had, so if anyone does raise a hand, you'll have to interrupt me.
Oded, go ahead.
Regarding the MCDC,
Yeah.
where do I see the coverage of the MCDC in the Cantata ID?
Yeah, sure. So so if I switch back to the IDE, there will be I think we're working this one. Inside here, there's a full log file that comes out. So I showed you the HTML report, which is the nice, friendly kind of project manager overview that everything is passed. In the more detailed log file that comes out, again, we've got all of the data that's being passed around, but towards the bottom, we've got a full block of coverage information. So these are coverage results that cover every metric that we've selected in that initial set. So in here, we've got entry point, call return statement, and decision. And we can scroll down through. We're highlighted to exact lines of code. We can see how many times things have been executed and not executed. And I think this piece of code doesn't actually have any complex booleans in it. So there probably won't be a specific MCDC coverage, but if we were testing code of that type, it would come out in this format here. So this is an ASCII results file. So the whole ethos with Cantata is that it's kind of standard developer-friendly format files, both input and output. So the test script that I was talking about is simply a piece of C code. So we generated a piece of C code that means there's no kind of additional learning kind of on-ramp for people using the tool. They can open up the code that's driving the tests. If they're familiar with reading C code, they can kind of figure out what's going on inside the Cantata test script. Lots of other tools that you may be familiar with. Some of them have a more complex way of setting up test data in some kind of IDE system. We have that available as well, so we can modify input and output data expected output data in an IDE. But the beauty of Cantata is all of that data is stored as pure code behind the scenes. On the output side, we've got the HTML, which is obviously standard format. The text results log, which is just a text file, can be read on any machine, any piece of software. And we also have, with an add-on pack that we're going to be bundling with the next version of the tool, JSON format, both for the input and output. So you can define your test data in a JSON format, and also view all of the results, including all of the coverage results, in a JSON format. And it just makes data easier to pass around between various tools that you may be using in your workflow.
Just to clarify, so this test break, was it defined with the coverage rule set of MCDC coverage?
So I think I did. I switched halfway, so we weren't waiting for things to compile. So this is the one that I set up live. Let's just try and run that. You're asking a question that I'm not sure the answer to until I actually look at what the tool does. So this is the one that we set up with MCDC coverage. Let's have a look at the results. Now, I'm not sure if, because we've not got any of those complex Boolean expressions, that section will be empty, or we may have, there we go, Boolean operand effectiveness. So that is MCDC coverage. So that information is appearing in these results. Because we don't have any complex Boolean expressions, then we will be getting 100% coverage of that metric in this case. There's a few cases where we're not exercising branches, and those are the areas of unreachable code in this example.
Yeah, it was to mention that this was generated by the auto test feature. Means that the tool automatically produced the test script.
That's right. That's correct. Yeah. So here we go. Scrolling through while you were talking, I found on line 1000 of the output, we've got a section here for Boolean operand effectiveness, so the MCDC. And I was wrong when I said I didn't think there was any MCDC statements in here. Obviously, on line 130 of break.c, we've got some conditions that meet that criteria, and our auto test generated tests have fully exercised that. So we could, let's drop to line 130 of break.c and actually look at what's going on there.
Yeah, the auto test is a very cool feature because it saves you a lot of time. Instead of manually create the test, auto test help you to, with the infrastructure, to create all the tests together.
You're right, Ohad. Auto test is cool, and it's been cool for about 10 years. What I was about to drop into was something even cooler, which is the AI-driven enhancement to that auto test. So in that first example, we've just algorithmically analyzed the code, and we've come up with test data and ways to hit different paths in that code. Just by looking at the mathematics, we're testing the code does what the code actually does. With the AI in the system, what we can do is test the code does what the requirements say the code should do. So I've got the same piece of code here. I've additionally got some requirement information, and I can open up an agentic coding tool. So we work with all of the main AI agents. I preloaded them just to step through. So I'll probably use Codex in this system, in this example, which is the OpenAI agentic coding assistant. Cantata can also be controlled by Claude Code, which is some people say the best agentic coding environment currently. We also work with GitHub Copilot, which many organizations are starting to adopt. And if you don't have an agentic system currently, we also work with open source agentic systems. So open code is one such AI agent, you can freely download this, point it at an AI model, whether that is a commercial model or something that you're running and hosting locally within your infrastructure, and you get full agentic kind of coding abilities without having to lock yourself into one of these commercial solutions. So I'm going to fire up Codex here. I'm not sure how many of you are familiar with these agentic systems, but most of them run within a terminal session. So this is a terminal that I've started inside the directory that contains these requirements in this code. And I can ask the agent to do different things. So I could say, analyze break.c, check for any bugs, and the AI agent would go away and do that. Our integration with these tools provides an additional pack of skills. So I can ask Codex what skills it's got available. It's got some generic ones that come with it, but you can also see down at the bottom here, we've got Cantata test automation. So that is a kind of a module that Codex hooks into that allows it to both read and write Cantata test scripts and Cantata results, but also operate the full functionality of Cantata agentically within this terminal interface. So I could ask the agent, what can you do with the Cantata skill, for instance, and it will have a look at that add-in pack, figure out what is in this directory, and it should come back with some information telling us what it can do. Let's proceed. So it's reading the skills pack here, figuring out the capabilities of Cantata, and then it's coming back with an answer. So Cantata's skill is for automating C++ unit testing, which we know about, can create Cantata workspaces, analyze source code, handle both C and C++. Basically, everything that a human operator can do with Cantata, this agent has the ability to do it. Now, you can set this going with something quite complicated. So if I've still got, no, I haven't. So I did have in my clipboard a pre-typed prompt, just so I didn't have to type too much in one go, but it's this one here. Let's copy that, put it into our coding agent. So in this single prompt, let's just set it going while I'm talking. I'm asking the agent to analyze that requirements documentation. So remember, that was a few hundred lines from our requirement system that explains the code. Then I'm asking it to create a new Cantata workspace. So this is a brand new directory. We haven't got any historical tests or testing work or any Cantata files in here currently. So it's going to create a brand new Cantata workspace and build tests for motor.c and break.c, and where possible, prefix the name of that test with the relevant requirements number. So if I just show you back in our auto test, our classical auto test system, this one, we came back with a number of tests, but there's no relation here to the requirements. So everything is just generic test 1, test 2, right through to test 33. There's no information telling us in plain English terms what that test is there to do. It explains why it's put that test there in mathematical terms. So it's inserted a test 24 to solve the true case of current pressure is greater than max brake pressure. But that doesn't really tell me a lot without diving into the code base. What we can do on the agentic side is start tying these things together. So I could let this run through. It runs completely autonomously, going backwards and forwards, building test cases with Cantata, running those tests, looking at the coverage that we've got coming out. Typically, that run takes anywhere between 5 and 15 minutes, depending on the speed of the underlying AI brain, AI model that we've got running here. So I did this demo yesterday and it took around 4 minutes. I'll give it a few minutes, kind of just approving file readers and writes. And we should get to a point where it's read the source files, read the requirements, understood enough, and then starts to operate Cantata. So we can see here it's figured out there's no existing Cantata workspace directories, so it's going to create some fresh ones. We'll let it do that. Give it a few more minutes. So it's actually operating Cantata behind the scenes, and we should start to see additional files pop up in here.
Adam, if I understand you well, you tell the AI to generate the test, and then
Yes.
the AI automatically read the file, the log file with all the results, and then you close the loop and make a test again.
That's right. So aside from typing that initial prompt, I've given this Cantata workspace appear. So this is brand new test code that the AI agent has put together. We can see that we've got a section for brake, a section for motor. We can jump in here and we should be able to find the Cantata test script that this AI agent has written. So at the moment, it hasn't come up with any test cases, but if we allow it a bit more time to run through, it will come up with the test data. I've got a complete
Can I ask a
run
question?
through. Yes, of course.
So when you generate the test cases with the AI, which is great, what is it with related to Cantata that gives it another edge? I mean, in terms of like, any AI, theoretically, you can say generate tests on this code. So what is it here in Cantata that the generation is specific? Like, for example, it creates the test scripts to meet Cantata typical form,
That's
any
right.
other elements. So I'm trying to understand, like, what is the integration here with the Cantata that the AI is, how does it, what's the integration part here that?
So you've got to think, why do people use Cantata from the outset? You could 5 years ago manually write tests to drive code. The reason people use Cantata is that we've got the test harness in place that has been certified, so that you know if you're calling a piece of code and you're checking the response from that piece of code, if you're running that call and that check with the Cantata test harness, the test harness has been certified externally, and you'll have no problems with certification of your own tool if you've used that test harness. We've also got the Cantata coverage results, which are again certified. So if the AI agent gets a Cantata report that says maybe one branch of MCDC wasn't covered, it can trust that. It knows that the Cantata results are definitive, and it can go back and generate a test case to fill that gap. So we're giving the AI a kind of industry standard framework to operate, which kind of forces it through a very well-defined workflow, a workflow that has been industry standard for 30 years or so.
Well, that's a great answer, so thank you. And I also wanted to ask, when generating tests with Cantata auto test, for example, then it typically, to my understanding, uses some kind of process. It doesn't only rely on the text of the code files, but there's also a process there where there's a build that is being done before that,
sure.
right?
So
and it uses that data. So is
That's
this
right.
data also being used when generating tests with
It
the AI?
is. Yeah, it is. So rather than watching it go through live, which is a little bit slow, I've got this is a Claude Code trace viewer. So this allows me to view the logs of a previous run that I've done with an AI agent. So we can see my initial prompt here. This is what I copied into the live run at the beginning. I can set a timer going at that point, and I can scroll down through this log to see all of the individual thinking steps the AI agent has gone through, and also all of the tool calls, if you like, all of the command line calls that it's run. I can look at the files that it's reading at each point. So at this point here, 25 seconds in, it's figured out it needs to create a Cantata workspace. A little bit further down, we should see a tool call for it actually invoking some command line Cantata usage and putting together that workspace. If I scroll down to the bottom, so what we about 10 minutes in here, we should see it going through. Okay, so at this point, it's created workspaces. Now it's creating test scripts. At some point here, we've got a tool call that it's made to actually run the makefile against those tests. So at this point, it's taken the test code that it's written, built that with our compiler that we've got set up, and actually run the tests. And then further down, it's doing an analysis of that output. So this log file here is the command line output. And we could see, open up again, we could see those tests are passing. The AI agent then gets that information, these tests pass. Now it's going to move on to the break test, so it's going to do the same thing, compile and run the tests that it wrote for break. Break.c had, or it's got some deliberate errors in it. That's coming back with an error result there. We look at the output that it's getting from Cantata. We can see that we've got kind of warnings in there. The AI agent knows the test has failed. So then it's analyzing the log file. So that detailed text file that I showed you in the first part of the demo, the AI agent is reading that to figure out why those tests are failing. And then it can infer what its next move is going to be based on that result. So it's come back saying there's several gaps, they're dead code, and there's a bug in break.c. Actually tells us, or it actually figures out what line that is, what function it's in. And I think if I scroll down to the bottom, when it finishes its automated run, it actually tells us. There we go. So there's a 13% coverage gap as a result of dead code in break.c. So this is a human readable summary that the AI agent has come through. This is at the point it finishes that run from that one initial prompt to start it. And it's actually telling us where the bug is and why that piece of code is dead code, why it's unreachable. So it's figured out in what was that? That's 15 minutes with Claude Code. Sometimes it runs through a lot faster depending on the current performance of the agent. Yesterday I had it running through in about 4.5 minutes with Codex to get to the same point. If I was manually looking at this, if I was a new engineer looking at a piece of code and scratching my head over why I'm unable to get full coverage for some reason, I'm probably talking about days or weeks worth of work to get to this point. So I'm not saying this is definitive and it doesn't need checking. It does. It needs a human to sign off on these results, but it's a much, much faster way to penetrate a new code base and come up with initial sets of tests that are actually tied into the requirements of that system.
Adam, 1 second. There is a question from Anna. Anna, can you ask, please, so everyone can hear? Basically, she is asking about integration
Yes,
test.
hi, I'm Alfred. I'm here with Anna as well.
Hi,
And
hi, Alfred.
Hi, nice to meet you.
And you.
Thank you. From the reports, we see that at least what I'm seeing is there is a hard link with the two line numbers in the source code. What happens when the source code changes? The break.c in a few weeks will change. All of the reports is hard linked to specific line numbers.
Yeah, so you just rerun them. So rerunning tests in Cantata is literally just calling the makefile build system that Cantata generates and rerunning and regenerating the reports, and all the line numbers get refreshed. So every time you run a test, it compiles the current state of the code against the test code, and the reports are regenerated for you. That's why it's an ideal system to drop into like a continuous integration pipeline. As the code evolves, the reports will evolve with that code. I'm not sure we've got time now. We've only got 5 minutes left, but yesterday I ran very similar demos. I had a very similar question: what happens if the code changes? And in that demo, I made a live change to one of the header files that this break.c and motor.c uses. So I think I changed one of these values from like 15,000 to 10,000. And then I went back to my AI agent. It's still running the initial tests here, but yesterday it completed. I went back to the agent and I said, I've made a change to one of the header files. Could you tell me what impact that's going to have on the tests and if it breaks any requirements? And within about 30 seconds, it had analyzed that change, told me what the impact was, and suggested maybe I'd want the agent's help in updating the tests, and hints on how to update the requirements to accommodate that change.
Okay, thank you. We have another question.
Yeah.
There are many common frameworks for the testing, like Google test. So do you have a combination of this test behind the Cantata GUI?
Yeah, so Google Tests and Cantata are very similar in terms of methodology. Cantata obviously has kind of more useful features in safety critical certified contexts than Google Test does. So the first thing that springs to mind is our concept of wrapping, which allows us to take external calls from a piece of software under test, surround that with some code hooks, and modify during the test run the data that's being passed to and from those external calls. That kind of feature isn't there in Google Tests. With Google Tests, you need to completely come up with stub or mock code for external calls, which kind of constrains your thinking and gives you more work to do. But there's lots of features like that in the Cantata test harness that go above and beyond what's in Google Test Harness. The other major issue with Google Test in safety critical context is that Google Test Harness isn't pre-certified. So the onus on certifying your test framework, your test code, your test scripts falls to you as the user of that harness. So as well as getting your own software through the certification process, you also need to get the Google Test Harness through the certification process. Now, that is possible. We've worked with customers that have tried that, but it's a very difficult thing to do. It takes months, if not years, to get through it, and you've got to justify the thinking that's gone into the Google Test Harness to the regulator. And when you're not the developers of that code, that's a very challenging thing to do. To help solve that problem, Cantata does have a Google Test mode that you can add into it. So if you already have legacy tests written with the Google Test Engine, you can run those through the Cantata test engine instead, and get the Cantata certified results coming out. You're using the Cantata certified engine, and you sidestep the headache that you might have trying to get the regulators to approve your use of Google Test.
Okay, thank you.
Okay. I'm not sure if I really pointed out the benefits of linking into requirements. So I've just opened up the output of one of these AI generated test scripts, and I want you to compare both the test name and the test description that the AI agent is putting in here. So we've got in the test name a link to a particular requirements reference number, and in the description, I don't know if you remember back, I showed you the algorithmic description that comes out of our classical system that kind of explains why a test is there in terms of solving some mathematical branch through the code. We've actually got something that's much more human readable coming out of the generative AI system. It knows vehicle speed, it knows why that's there, and it also links or references back to that requirements. So rather than just linking code to tests, with this system, we're linking code to tests to requirements. And if any of those kind of pools of information changes, you can ask the AI agent what the impact of that is going to be, and it will start to dip into that. In playing around with the system, something else I've noticed is, so it was coming back and telling me, and the AI agent was coming back and telling me that in some cases, the comment that was baked into the source code that I'm testing didn't align with the actual functionality of the code beneath it. So in algorithmic test solvers, we're just looking at the code constructs and figuring out what numbers are going to drive high coverage. With the AI agent in the loop, it's inferring information from the surrounding code comments to help it in its decision. It's also inferring information from the function names that you may have selected, or the variable names. So to an algorithmic solution, slip ratio is just a number. To an AI agent, slip ratio actually infers some kind of usage, which then means that the data, the way it's testing the code, is much, much more realistic than if you're just relying on pure mathematical solutions.
Adam, I have a question.
Okay, sure.
We saw that the agent can help you reach 100% code coverage quite quickly because it can generate more tests till it check that the percentage go up to maximum. How do you know that you need to stop generating more tests? Because if I understand well, to reach 100% coverage is not enough sometimes.
So I would point you back to where I started and say go to Amazon and buy my book. But yeah, the safety, the standards that you're working towards will say or define a minimum amount of coverage that you want to get, and that coverage depends on the safety integrity level you're working towards, but it will be like 80 to 100% for most of the metrics. If you think about it, to exercise a line of code 100% basically means you need to exercise it once, and that's all you need to do for most of these standards, just exercise each line of code once. Now, as an engineer, that is a little bit horrifying. You want to apply some thought process behind that, and actually do some kind of robustness testing on vital pieces of the code. Rather than stopping when you get to 100% coverage, you want to go beyond that.
Exactly.
And think about how to drive it. Usually, if you're working in a safety critical industry, kind of the amount of testing required will be defined in the requirements. So if we look at a particular requirement here, there we go. So this function PWM duty cycle, the requirements say the unit test should use these values. Now, it might be that mathematically just one of these values will get you to your 100% coverage, but the person writing the requirements knows that that isn't going to be sufficient in reality and comes back with a whole range of values. So the number of tests being returned from the AI system, because it can read these requirements, is usually a lot higher than if you're just stopping when you get to 100% coverage.
And another question, once you have the AI working, you don't need the Cantata IDE anymore. So it's only uses
Yeah,
it?
yeah, so I would say you do. So I've done all of the AI stuff inside VS Code, but behind the scenes, we've got all of the Cantata files. We can look at the results files. We can look at the test scripts and so on within a kind of text editor. But you also retain the ability to jump back into our IDE at any point. So this is showing us some previously generated AI tests. I can verify that because if I go into one of the tests, you can see we've got requirements numbers linked throughout in the test name and test description. As a human reviewing these tests and maybe wanting to make some small changes and quickly rerun those tests and look at the impact of the results, having this kind of more graphical IDE with all of the plugins to make it easy for me as a human to drive is quite useful. The AI agent doesn't need to drive this UI because Cantata can be fully operated on the command line. So that's why it's kind of abstracted a little bit. Does that help?
Okay,
Yeah, cool. That's good.
Okay, before we finalize, we have here also Eyal Gerber from Novodesk. Eyal helping us as a front end and helping customer to adapt the Cantata. So Eyal, you can have a few words to tell about your services. Eyal is from Novodesk.
Yes, hi, thank you, Ohad. And hi, everybody. I just wanted to say a few words about myself. My name is Eyal Gerber. I'm from Novodesk. We work with SiteSys, with Ohad, on the various tools that they help sell that help improve quality of software. One of them is Cantata. We've done several projects in Israel with critical systems, companies that develop critical systems and that require these high level of quality in their software. So if anybody needs any kind of help, right, with implementing Cantata, integrating it, even in part of their CI/CD, setting up a CI/CD, writing all the tests and the integration tests within Cantata, right? You can do both unit tests and integration tests. All of those stuff we can help you with. So just wanted to let you guys know that I'm here also if you need as extra support for SiteSys and for Cantata. Thank you.
Okay, thanks, Eyal. Adam, thanks a lot for the time. I think it was very informative, and all the audience, thanks to you as well. If you have any additional question later on, feel free to drop us an email and we will get back to you. Adam, thanks again for the informative session.
No, thank you. I'm happy to answer any questions that come to you later. So feed them through to Ohad, the organizer, and if he needs some additional support in answering questions, I can be on hand.
Okay, great. Any other question? Anna, do you have another question or it's done?
No, thank you. Thank you very much.
Okay, thanks a lot, everyone. And
Great, thanks. Have a good day, everyone.
Thank you. Bye-bye.
Bye-bye.
Bye, thank you. Bye-bye.